So, what is a robot? A robot can be defined as a machine which is assembled by a human being and able to replicate certain human movements and function automatically. There can be various definitions for a robot. It can be defined as a programmable machine dedicated for a particular work and has some features of a human being. So let us see different classification of robots. So there are various types of robots such as variable sequence robot, a playback robot, a numerical control robot, an intelligent robot. Variable sequence robot signifies let me tell you, variable sequence robot means a device that can perform successive stages of tasks to a predefined method and easy to modify those tasks. Perform successive stages in a predetermined method. Whereas a playback robot is like a human operator which perform tasks manually by leading the robot. And another classification is numerical controlled. In this, the operator supplies the movement program that means if you want to move the arm, the operator will give the command. So it is a program which is loaded in the robot memory. So the operator, depending upon the task, will load that program. The best example, you can search KUKA robots. Even Tata has their own robot, and there are so many companies which are producing this type of robots. These type of robots are generally used in industries and factories such as car manufacturing and other production works. Then we have intelligent robot. For the intelligent robot, you can see these are like humanoids, a replica of human beings. It is able to understand environment and it has the ability to successfully complete a task despite the change in environment also. Next classification are depending upon the complex tasks the robot can perform. Let us see the application of sensors in automatic robot control. As the human have 5 senses which gives the feedback of the environment, similarly the machine, the robot, must have some sensors which gives it a feedback of the environment, which can sense the physical parameters, and the robot can take an action according to the input given by the sensors. So what is the role of sensor? The sensor is giving the input to the robot. Okay, so to accurately achieve a task in an intelligent environment, the robot has to be able to react dynamically to the change in surrounding. So Sensors provide input from the surrounding. Based on this input, the robot can act. It dynamically changes according to the surrounding. So the robot control architecture, you can say it needs a sense. It will plan or process the input and it will act accordingly. It is similar to a human being architecture. We take input from our eyes, nose, ears, skin, and the temperature. Then our mind process it, and then we behave according to that input. So the plan or process, this is like a human brain analogy. It has memory also, and it has logic also. So similarly, robot will also have the memory and the logic and the processing unit. So it can be a hierarchical or deliberative robot control architecture. It can be a reactive robot control architecture. It can be based on behavior robot control architecture, and it can be a hybrid robot control architecture. In a hierarchical or deliberative robot control architecture, hierarchical, or you can say deliberative robot control architecture. What happens is, all these three blocks, sense, plan and act, these are connected in a hierarchy, and then after the action, the sensing action will be taken again. If there is any difference between the desired action and the action taken by robot, the sensor will again give the input, it will again process the input, and then again the action will be changed. So the perception, modeling, planning, task execution, motor control, this type of action can be based on deliberative robot control architecture. Now let us discuss the reactive robot control architecture. Reactive type architecture, it is simply based on the sensor input. As the law says that every action has equal and opposite reaction, so it is same like that. We have sense and we directly give action, and that action will cause again some change in the sensor. So there is no plan or no program in between the sensor and the actuator. These are just based on the reaction of the sensor, and that reaction will cause the back action on the sensor. It is a direct mapping between the sensor input and actuator output. It is very reactive to change in sensor reading. Then the third architecture is the behavioral. In the behavioral based architecture, it means the sensor sees the reason behind the behavioral change. We are talking about smart sensors here, which are used for robots. It plan changes. It identify objects. The sensor value is given to the central process unit, and that process the reason behind the behavior changer. It may build the maps, for an example. It may avoid the object and then take some action. It can give the value to the motor, and the robot can change its direction of the course. So the robot actions are determined by the set of parallel reactive behaviors which map sensory input and the state to the action. Now let us discuss hybrid robot control architecture. In a hybrid architecture, we have sensing part that can directly give into the action, and action can directly give its reaction on the sensor. But in between we have the plan or the process part, also processing part, which whenever required will give the command to the sensor as well as the actuator. So this is a hybrid type of architecture. It is a mixed type of architecture. So these are the different architectures of robot control. The classification of those sensors used in the robot can be based on, like, it is used for touch, it is used for force measurement, it is used for vision, proximity, heat, for heat measurement, it is used for sensing the presence of light, etc. The position sensor can tell the robot about the movement, how much it has been traveled, and how much it has to travel furthermore. The velocity sensor can give the velocity and measures consecutive position measurement at the non-interval and computes the time rate change of the position values. So there is a wide application of sensors in robots, and that can help the robot to take the further decisions.